Hi all, I'm going to show you how to do two exercises that follow from the lesson on graphs and how to interpret shapes of graphs from equations. This is a skill that you're going to use throughout the year, so I thought I would address it, tackle things right now to figure out what you aren't catching. It's important that you know the shapes of various functions, and that was on the third page of your notes. You should know linear, you should know quadratic, square root, inverse especially. And that pretty much covers it. So I'm going to go through some actual equations and then show you what the graph should look like, how you figure it out. And then if it's a nonlinear graph, what you would plot variable-wise to get a linear graph. And then on the back, I'm going to show you how to do proportions. Okay, proportions kind of follows from this. It's a slightly different problem, and students usually struggle with it, so it's good for us, again, to tackle it head-on right now. All right, so what I have here is a chart of, I don't know, 7 or 8 equations where I define the x and y variable, and then anything else that's an equation would be a constant, would be a number. So it might be a 5 or a 50. We just label it as a letter because it represents something physical, but it's not changing in the situation. So what I want you to do in this column is put the variables where they belong and then sketch the shape of the graph based on the equation. And then if it's nonlinear, then linearize it. Okay, so I'll do probably the first 3, and then the rest I want you to do on your own. And then I'll go to the back. Okay, this is how you approach it. So my equation is right here, f is equal to m times a. X is a, so I'm going to put an a here, y variable is f. So I'm going to put it here, and m is constant, meaning I can ignore it. This m might be 50, but it's staying the same. So I'm doing some experiment where I'm changing the a and seeing how f changes. So let's assume that m is staying constant. It's our control. So what that means, okay, in terms of proportions, is if I ignore the m, I'm basically saying f is proportional, so here's my symbol for proportional, to a. They're directly proportional, and if you notice, they're the same power, okay? So that's basically saying y is proportional to x, and that we want you to recognize as a line that passes through the origin. Okay, pretty straightforward, all right? Don't have to do anything with linearizing because it's already linear. If there was a plus sign next to it, then it would just shift things to a non-zero y-intercept. All right, let's move to the next one. All right, we have k is 1/2 mv squared. So my x variable is v, and my y variable is k, and once again, m is constant. So I'm going to take this and ignore everything except for my variables, and my proportion is k is proportional to v squared. That's, if math, that would be essentially the same as saying y is proportional to x squared. So that's definitely not linear. The squared part suggests strongly that it's a quadratic, so I'm going to draw a nice parabola. You're going to see a lot of quadratic relationships in this course. Now, I want to linearize it. I want to plot a set of data of k and this to some power that gives me a straight line. If I plot just k and v by themselves, I can't get a straight line. I'm going to get that parabola. So the idea is, if I'm saying from the equation that k is proportional to v squared, proportional means a line if I plot it. So I literally put k here and v squared there. And if I put in numbers, I will get a straight line. You could try that yourself if you want to. Make up an equation where you say k is equal to 5v squared. Put in numbers for v and k and plot them. You'll get a parabola. And then if you do k and v squared, you'll see you get a straight line. All right, last one. T is equal to d divided by v. Our x-axis is v. Our y-axis is t. And d is constant. So what I'm basically saying is t is proportional. Now let's be careful. If I ignore the d, that doesn't leave v. It leaves 1 over v. Okay, because v is in the denominator of that equation. That's not linear. That would, if t was proportional to v, then I get a straight line. It's not quadratic. There's no squared in there. So this is, again, similar to y is 1 over x, and we want you to recognize that as an inverse. In other words, as x gets bigger and bigger, y gets smaller and smaller. The shape of an inverse is a hyperbola. Okay, the common mistake that I see, and I'm sure I'm going to see it, maybe not in this particular problem, but later on, is don't draw this. Is going to be a linear, a negative linear. okay, that is not an inverse. That's saying y is proportional to negative x. The equation is telling us y is proportional to 1 over x, or really t is proportional to 1 over v. All right, so that's nonlinear. I got to linearize it. To linearize it, I just literally take my proportion, and that's what I plot. So I'm going to put t on the y-axis, 1 over v on the x-axis, and if I plot those, I would get a straight line. And I'm just going to say a few things about this last one because I don't know if you're quite understanding why you'd get a straight line if I plot those. So if I were to make some equation, let's say I would say t is equal to 1 over v, and I were to make a table of v and t, right? Let's say t was 1, 2, 3, 4. So t would be 1 over 1, then 1 over 2, which is 0.5, 1 over 3, which is 0.33, and then 1 over 4, which is 0.25. So you can clearly see as v gets bigger, t gets smaller. And if I plot those points, I would get the inverse. Well, what if I want to get a straight line? Well, what we just suggested is we would plot t versus 1 over v. So if I make another table of t and 1 over v, so follow along. Whoops, I'm going to switch that around. I'm going to put 1 over v as my x-axis. Okay, so my original v was 1, so I'm now going to do 1 over 1. 1 over 1 is 1. Then my second v was 2, so now it's 1 over 2, which is 0.5. Then 1 over 3, which is 0.33. And then 1 over 4, which is 0.24. And my t values, I'm still plotting the same t as before. So that's 1, 0.5, 0.33, 0.25. And sure enough, that's going to give me a straight line with a slope of 1. If I had a 2 here, then I'd still get a straight line with a slope of 2. So try the rest on this. It's really just variations of the what I've shown you. Let me just say something. If you see your variable in the denominator, it's got to be an inverse. Oh, one last thing on this one. I could also have plotted 1 over t versus v and gotten a straight line. Okay, so that's allowed. You do that. I would just get a different slope than the other graph. So let me turn our attention to proportions. The idea behind proportions is, in many cases, if I have a relationship and I say, well, I'm going to double this, what's going to happen to that? I should be able to say directly what's going to change without having to actually put numbers in. So for example, let's take the first equation from the back on the front side where we had f equals ma. Suppose I said, all right, we're going to double our f for a given mass, meaning mass is staying constant. How, by what factor, okay, would a change? What I'm asking is, how much would it be greater or lesser in terms of proportions? Would it be double, triple, a third, a half? That's all we're looking for. There's a lot of different ways to approach this problem. I'm going to show you the formal way, just so you have something to follow from here on. If you have shortcuts, and I have plenty of shortcuts, you can use those. But if you don't have those shortcuts, then follow this process, try them for all the others, and hopefully things will make sense. So here's the process for doing proportions. Okay, I start with first of all, I need an equation. So we're relating f to a for a given m, so I need an equation with all three of those in them, and that's, of course, f is equal to ma. I want to know how things are going to change, so I'm going to have a new f. I'm going to call it f2. So I'm basically looking for what is the ratio. Okay, excuse me. It is given, I'm sorry. What I'm looking for is the ratio of my new acceleration, a2, to my old acceleration, based on my new force, f2, over my old force. Okay, since everything's to the first power, I'm just going to leave them as they are. Again, the m is ignored because it's staying constant in this, so in proportions-wise, it's just going to divide out. It was given that f2 over f1 is 2. Okay, it didn't come out and say it, but when we say f was doubled, that implies the new f is equal to double the old f. So it would follow then, if I put in for this whole thing 2, then my new acceleration over my old acceleration must be 2 as well. In other words, a will double. Okay, so in any linear relationship, that's always going to be the case. If you triple something, you're going to get the triple of the other, and so on and so forth. So that's the easiest one to deal with. Now let's look at one that's not so obvious. I'm going to go to 1b. So it's the same equation. This is equation 2. Equation 2 from the front was k equals 1/2 mv squared. Now I'm going to double v for a given m. I want to know, how does k change? So what am I looking for? I'm looking for a change in k, so the way we represent that is a ratio or a proportion. I want to know what my new k is over my old one. Okay, so k2 over k1. I ignore the half and the m because they're staying constants. So my proportionality is k is proportional to v squared, as we established earlier. So that's got to equal my new v over my old v. Then the whole thing, it's got to be squared, and that's the key because of the squared right there. So now I can substitute in. I'm looking for k2 over k1. So what's v2 over v1? Well, v was doubled, so my new v is double my old v, so I put 2 in the parentheses. I make sure I square it, and that of course is 4. So my answer is, my new k to my old k is 4 times great. I've quadrupled k by doubling v, and that's the hallmark of a quadratic. Okay, so hopefully these will lead you to success on the rest. As always, if you're not catching something, do your best to continue answering it and then ask questions or show me, circle things, what you upload so I can give you feedback.